Today we're going to do a terminal velocity exam question. Now in a terminal velocity question, quite often you will see a graph, or that you'll be given a graph like this, which will be a velocity time graph. So being able to understand that a curved line going up is accelerating, this is going at constant speed when it's horizontal, a line going back down like this is deceleration. So you need to be able to recognise what's happening to that object based on the graph. The other key thing to remember with terminal velocity is your first and second law for Newton's laws. Your first one, if we're keeping it very simple, it's all about your forces being balanced. So these are paired forces, they're equal, arrows are also equal in size, and your resultant force is 0. Newton's second law is basically these two forces, but they are unbalanced. So you represent them in different sizes. The arrows will represent the size of the force and they have to be different. Use a ruler if needed to make sure that you represent those two arrows differently. The resultant force will never be 0. And what's occurring here is that your object will be either accelerating or decelerating. And it's linked to this equation where your force is equal to your mass times acceleration. They are linked together. Your mass will determine how much force is needed to accelerate. So if I go back to first law, this will mean that your object is either stationary or it's going at a constant speed if it's already moving, which applies in terminal velocity. So your paired forces when someone is falling is your gravity, and that's acting downwards on that person, and it will always be 9.8 or 10. Your paired force here is air resistance and it's pushing you up. This is the force that will change as you fall. So the exam question, this is a very typical one. It says using the idea of forces. So you can annotate by saying that's your gravity and your air resistance. I'm keeping it very simple with my writing. This is what you should be doing for a 6 marker. When you first get your question, you should be first minute annotating the diagram like I have done here. Find out, you've got 6 marks. What can I write about? What sections can I write about that will make up my 6 marks? So I've highlighted here areas of the graph that I can talk about in my answer to get those 6 marks. So need to talk about the forces. So identify those. Explain is your command word. So you need to do the science. You need to explain the science. And then terminal velocity, I know that terminal velocity is when it's going at a constant, so that is your first law. And why opening a parachute reduces that terminal velocity. So identify the 2 terminal velocity points. So here, and you can write that is going to be about 60 meters per second. Here, this one, can't measure it exactly, but it's just under the 10. So represent that as well in your speed and in your answer. That shows the examiner that you can also read a graph, which is quite relevant, and that might be in the mark scheme as well. So annotate the diagram and then talk about the different points on the diagram in your answer. I have simplified this because in your answer you'll be writing in full sentences, but your full sentences should be able to describe what's going on here. So you talk about the first bit here when they jump out, your only force really being applied initially straight away is your gravity, 9.8. This arrow should always be the same throughout the journey. It's your air resistance that changes. So initially when they jump out, you're going to get that small air resistance. So this is this, and then that, because there's a greater difference, you're going to accelerate at a higher speed. That shows here with the gradient. As they fall, your air resistance will increase. So you're hitting more particles because you're going at a faster speed. So this arrow should now be getting bigger. And you can explain then that you are still accelerating, but you're accelerating at a slower rate. And this is Newton's second law. All of this is Newton's second law, apart from when you reach terminal velocity. So we can talk about that for section 2. And then section 3 is reference to the forces. They are equal and balanced, Newton's first law. So they are equal, therefore the parachutist is going at a constant speed. Then when they open the parachute, which is what they want you to talk about here, you are increasing your air resistance. That surface area, and mentioned surface area as well, has greatly increased. So you're going to hit far more air particles and create a bigger air resistance. So your speed will very dramatically, as you can see with the gradient, reduces. And then they will reduce until, again, 0.5, you reach a second terminal velocity, where they're, again, balanced forces. And then 0.6 is when they hit the ground. There's no more air resistance or whatever, so they stop. So just to recap, your 6 mark, 1 minute annotating, 4 minutes you should be writing. And my helpful hint is go on to another question or two, and then use that final minute allocated to that 6 mark, come back, reread the question, reread your answer, and check your writing and your answer. Make sure it makes sense, make sure that you've added all the key words to it, to the answer, including points on the graph, and then you should be happy. That's how you would answer a 6 marker on terminal velocity.